Hello and thank you for watching this video about magnets. Before diving too deep, let's go over some definitions. What is a magnet anyway? A magnet is an object that attracts certain kinds of metal, like iron. Some magnets look like this, others look like this, and some even look like this. Magnets come in lots of shapes and sizes, but they all do the same thing. All magnets also have ends or sides called poles. One is the North Pole and the other is the South Pole. Sometimes magnets even are pre-made to show the poles so that you know which is which. Around each magnet is a magnetic field. A magnetic field is the area around a magnet where magnetic objects would experience a magnetic force, a push or a pull from the magnet. The magnetic field lines around a magnet would look something like this, if we could actually see them. Wait, we can! This is a bar magnet surrounded by small iron filings. Notice how they all fall into the pattern of the magnetic field around the magnet? How cool is that? The strength of the magnetic field is different depending on the location. The strength of the magnetic field will always be strongest closest to the poles. This iron nail being close to one of the poles of the magnet means that the force of the pull will be very strong. If nothing is keeping the nail in place, it would likely be pulled toward the magnet and stick to it. However, this nail is far from the magnet's poles. The magnetic field is far too weak this far away. The nail may be experiencing a very tiny pull, but not enough to move it toward the magnet. It will stay right where it is. The poles of magnets interact with each other differently depending on if the poles are opposite or the same. When the poles of two magnets near each other are opposite, they attract one another or pull toward each other. Here we have two magnets. Notice how the poles that are facing each other are opposite. One is north and the other is south. Opposite poles attract each other, so if these magnets are close enough to one another and the fields are strong enough, they will exert a pulling force on each other until they eventually come together and stick. They will not come unstuck unless another force pulls them apart, like you pulling with your hands. If the magnetic poles facing each other are the same, it is a different story. Like poles, or poles that are the same, repel or push away from each other. So if we have two north poles facing each other, they will push away. If we have two south poles facing each other, they will push away too. Have you ever played with magnets and tried so hard to get two specific ends or sides to touch and they just wouldn't? Or they would, but would immediately release and shoot away when you stopped trying to hold them? That is because you were trying to put like poles of the magnets together, and those naturally repel.